On a stormy night in 1879, a train carrying dozens of passengers began crossing a massive railway bridge in Scotland. Everything seemed normal, until suddenly, in the middle of the storm, the entire bridge collapsed beneath it, sending the train into the dark waters below. And what makes this story even more disturbing is that the storm was not the real reason it failed. Before we uncover what really caused this disaster, subscribe now, because the stories on this channel reveal the hidden failures behind events that history often misunderstands. In the late 1800s, the world was changing faster than ever before. Industries were expanding, cities were growing, and railways were transforming the way people lived and traveled. Trains were no longer a new invention, they had become a part of everyday life, connecting towns, carrying goods, and making long distances feel shorter. And with that rapid expansion came a demand for structures that had never existed before: massive bridges. Long enough and strong enough to cross wide rivers and difficult landscapes, and among those projects was the Tay Bridge in Scotland. When it was completed, it was seen as a symbol of progress. Stretching across the River Tay, it was one of the longest railway bridges in the world at the time, an engineering achievement that people admired and trusted. Trains crossed it daily, passengers sat inside without hesitation, and over time, it became something ordinary, just another part of the journey. But like many structures built during periods of rapid growth, what appeared strong on the surface did not always reflect what was happening beneath. The bridge had been designed under pressure, not just the pressure of engineering challenges, but the pressure of cost, time, and expectations. Decisions were made to reduce expenses, materials were selected based on affordability rather than strength, and parts of the structure were built in ways that were considered acceptable at the time but would later prove to be dangerously insufficient. The iron columns that supported the bridge were not as strong as they needed to be, the connections between different sections were weaker than they should have been, and the overall design lacked the ability to handle extreme forces. But none of this was obvious to the public, because during normal conditions, the bridge worked, trains crossed it without issue, and that created a false sense of security, because when something works repeatedly, people stop questioning it. And that is often where risk begins to grow, quietly, unnoticed, waiting for the moment when conditions change. On the night of December 28, 1879, those conditions arrived. A powerful storm moved across Scotland, bringing strong winds that swept through towns and across open landscapes. It was the kind of storm that made people aware of the weather, but not necessarily afraid of it. Life continued, trains continued, and that night, a passenger train approached the Tay Bridge, carrying people who had no reason to believe that anything was wrong. Inside the train, the atmosphere was likely calm, passengers seated, conversations taking place, some perhaps looking out into the dark, others focused on their own thoughts, unaware that the structure ahead of them was already under stress. As the train moved onto the bridge, the wind pushed against it with increasing force, not just against the train, but against the bridge itself. The long exposed structure began to sway slightly, something that may not have been immediately noticeable, but the stress within it was growing. The supports were being pushed beyond what they had been designed to handle, the connections between sections were under strain, and the entire structure was experiencing forces that had not been fully accounted for. And then, in a matter of seconds, the failure began, not as a single dramatic moment, but as a chain reaction, one part giving way, then another, iron supports breaking, sections collapsing, and suddenly, the bridge was no longer a continuous structure. It became fragments falling into the river below, and with it, the train. The carriages plunged into the freezing water, disappearing into the darkness. There was no time for reaction, no warning that could have changed the outcome, just a sudden transition from safety to catastrophe, and then silence. The storm continued, but the structure that had once stood there was gone. In the immediate aftermath, the explanation seemed obvious. The storm had been powerful, the winds had been strong, and it was easy to believe that nature alone had caused the collapse. But as the shock began to settle, questions emerged. Engineers, investigators, and experts began to examine what had happened, and what they discovered changed the entire understanding of the disaster. The bridge had not failed simply because of the storm. It had failed because it was not strong enough to withstand it. The materials used were weaker than expected, the iron columns were brittle, the design lacked proper reinforcement, and the connections between different parts of the structure were not secure enough. The storm had not destroyed a strong bridge, it had exposed a weak one, and that distinction is critical, because it shifts the cause from an unavoidable natural event to a failure of design and decision-making. The disaster was not just the result of a storm, it was the result of choices made during construction. Choices that prioritized cost and speed over long-term safety, small compromises that may not have seemed significant at the time, but together, they created a structure that could not survive under pressure. and this is where the story becomes more than just a historical event. It becomes a lesson, because it shows how systems fail, not suddenly, but gradually, through decisions that seem acceptable, through risks that are underestimated, and through confidence that is not fully justified. In the years that followed, the collapse of the Tay Bridge led to major changes in engineering practices. Stricter standards were introduced, materials were tested more carefully, and designs were reviewed with a greater focus on safety and durability. Engineers became more aware of the importance of accounting for extreme conditions, not just normal use, and these changes improved the way structures were built, making them safer and more reliable. But those improvements came too late for the people who had trusted that bridge on that night, and that is what gives this story its lasting impact, because it is not just about what happened, it is about what it reveals. That safety is not something that can be assumed based on appearance or past performance, it must be built into every part of a system, tested under real conditions, and constantly questioned. Because the most dangerous structures are not always the ones that look unstable, sometimes they are the ones that appear strong, reliable, and safe, until the moment they are tested, and when that moment comes, the truth is revealed instantly, and often, it is too late to change the outcome.